Hi everyone, welcome to Chapter 6, CVP Analysis, Cost Volume Profit Analysis. This stuff is used a lot in many different businesses, so it's a very handy tool to have some knowledge about. I'm just going to run through a bunch of examples and talk about how we can calculate this stuff without memorizing long formulas. Let's start with M6.3, mini exercise 6-3. We're talking about a company that sells clocks. Their variable cost per clock is $6 and each clock sells for $24. We're asked to calculate the contribution margin per unit and the contribution margin ratio. And then we're given the fixed costs and asked how many clocks they must sell to break even. For all of these problems, if you start out this way, sales minus variable cost equals contribution margin. And then you put the stuff in. This is per unit, $24. Variable cost $6. That leaves the contribution margin at $18. And then the percent, if you get used to putting in the percent, it helps a lot too. 100%, that's 24 divided by 24. 6 divided by 24, it's a percentage of income. So 6 divided by 24 is 25%. 18 divided by 24 is 75%. So if you can reproduce this, or at least the per unit, you can calculate any of these problems. The formula to calculate break even is fixed cost divided by, and actually it's not just break even, it's break even per unit, because they said determine how many clocks they must sell to break even. So the fixed cost divided by the contribution margin per unit, because we want a per unit break even. So break even is equal to fixed cost, which is $6,660, divided by the contribution margin per unit of $18. So our break even is 370 units. Not dollars, 370 units, because we're dividing by the contribution margin per unit. If we wanted to know the contribution margin, or the how much in sales dollars they must sell to break even, we can take fixed costs and divide by contribution margin ratio, the 75%. But we weren't asked that in this problem. Then we're asked to take that very same information, which we already have, and tell them how many units they must sell to earn a profit of at least $5,400. So M6.4. So we're going to take the same formula, fixed cost divided by contribution margin per unit, except now we're going to take fixed and we're going to add the target profit to it. And then we're still going to divide by the CM per unit. So the break even, oops, it's not break even, sorry. Got carried away there. The sales to make that much profit is equal to 6,660, which was the fixed cost, plus the 5,400, which is our target profit cost, divided by the unit CM. Oops. Well, let's actually write the unit CM, sorry. And that would be $18. That's this number. So the sales to make that much profit would then be, not sales, in units, because we're dividing by units. Sorry, it's Friday. the sales in units would then be 670 clocks or units to make a profit of 5,400. So we can use the same information. All right. M65. Suppose they raise their price by 20%, but costs do not change. What's its new break-even point? Well, our original amount here was $24 in sales. They're raising it by 20%. So this is M65. And we're going to take the sales price of $24 that we originally had. And if we're going to raise it by 20%, we're going to multiply that by 120% because we want to take the original $24 plus an additional 20%. And that's $28.80. And then we set up our thing again, sales, $28.80. It said that cost did not change, so our variable cost is now $6. And our CM per unit is now $22.80. Fixed of 6,660 divided by the unit CM, which is $22.80, is equal to 292.105. But those are in units, and you can't make 0.105 units. So 292 units. Clocks. So we're still using that same formula. We just changed things a bit. So suppose their variable costs increase by 50 cents. What's the new break-even point? 6-6. So sales, always go back to the original. So it says refer back to M63, not M65 where we came up with a new sales price. M63 says the sales price is $24. Our original cost was, back up here, our original cost, oops, sorry, that was a different problem. Original cost was $6. That's going to decrease by 50 cents, so variable cost 5.50. That gives us a new contribution margin per unit of $18.50. Fixed, $66.60 divided by contribution margin per unit of $18.50 gives us new break-even point of 360 clocks. I think the thing that students mess up on the most is understanding that it says refer back to M63, so you've got to jump all the way back to M63 and change those numbers. Okay? We're going to calculate margin of safety now. Margin of safety is that place where it's the difference between breaking even and losing money. Wherever our sales are and our break-even sales point. How much can our sales go down before we lose money? So if Jasper Company has sales of 185,000 and break-even sales of 120,000, what's their margin of safety? So margin of safety is equal to actual or sometimes budgeted sales, minus, I should probably not be doing this today. I'm a little out of it on this Friday morning. Margin of safety is actual or budgeted sales minus break-even sales. So margin of safety is equal to 185,000 minus 120,000, or 65,000. So my sales can drop by 65,000 before I start to lose money. What might be more useful is the margin of safety ratio. So the margin of safety ratio is equal to the margin of safety divided by the sales. So our margin of safety ratio is 65,000 divided by the sales of 185,000, or 35.135%. So if our sales on any given day drop by that much, or any given month drop by that much, we know that we're headed towards a total drop of 35.135%, and we'll start losing money at that. Okay, everything we did so far presumes that a company only has one product. We all know that's not really true. So this company manufactures two products, and we'll just do a simple one, and many companies do way more than two. And here's the information for product A, and here's the information for product B. And this is the product mix. 40% of the production goes to product A and 60% to product B. We're asked to calculate their weighted average contribution margin per unit. So we still do the same thing. This is M6-17, and we're going to set it up sales minus variable cost equals contribution margin. And we're going to do this for product A and for product B. Product A, $13.50 with variable cost of $6.15 gives us a contribution margin of $7.35. B, $16.75, $6.85, and $9.90. So $13.50 minus $6.15 equals $7.35. $16.75 minus $6.85 equals $9.90. So now we have a contribution margin for each. The weight on product A is 40%. The weight on product B is 60%. So our weighted average contribution margin, we multiply those two together. $7.35 times 40% is $2.94. And $9.90 minus 60%, or times 60%, is $5.94. Add those two together, and that is $8.88, weighted average CM. So why do we need that? Because we need that to calculate break even. So now they're asking us to calculate break even. We have the weighted average contribution margin, and they're asking us to calculate break even if their fixed costs are $230,000. So M618 break even is equal to fixed divided by the weighted average, CM per unit. So our break even, and we're doing this in units, we're going to get a per unit answer because we're dividing by the per unit. Break even equals fixed costs of 230,000 divided by 8.88. So break even is 25,901 units, and that's rounded. But how much of that is product A and how much of that is product B? So product A is 25,901 times 40%, because that's our percentage that we're given in the problem. Remember, 40% goes to product A, 10,360 units. Product B, 25,901 total break even times 60% is 15,541 units. So to recap that, in order to calculate a weighted average contribution margin, you first have to come up with the contribution margin for each one, multiply it by the percent, add those together, and then you get a weighted average contribution margin. Then you calculate total fixed or total break-even units for the whole company, and then you multiply it back out at 40-60 ratio to figure out how much per product. Okay. I think I want to do one last example, and that's this one. So we've got E6-3. Holy cow. And we're talking about a local bakery here. They sell cakes. Their price per cake is this much. Their variable cost per cake are these three things. And their fixed cost per month is this much. We're asked to determine their break-even point in units and dollars. All right. So let's set up our thing. Sales, variable cost, contribution margin. Our sales is $17 a piece. Our variable cost is $2.50 plus $1.40 plus 20 cents. And that would be $4.10. Let me not put that in there. Equals $4.10. So that makes our contribution margin $12.90. And this is per unit. Let's do the percent piece. So this is 100%. And this is not a pretty percent, by the way. This is round the percentage to the closest two decimals. So $4.10 divided by $17 gives us 24.12% rounded. $12.90 divided by $17 gives us 75.88% rounded. Now, break-even point in units and sales dollars. Let me move this up so we can keep this on the screen. Our fixed costs are $38.50. So break even in units is equal to 38.50 fixed divided by 1290 cm per unit. And that's equal to 298 cakes. And that's rounded. Now I can do one of two things here to find break-even dollars. I can take 298 times my sales price of $17 and come up with 5,066. I can also take I can calculate break-even dollars by taking my fixed 38.50 divided by the CM ratio of 0.7588, and I will come up with 5073.80 break-even dollars. The difference is because of rounding. We rounded the CM ratio. If we hadn't rounded the CM ratio and just left that in the calculator, we probably would have come up with a closer number. Determine the bakery's margin of safety if it currently sells 450 cakes a month. Okay. This is the second part. Margin of safety is equal to current sales minus break-even sales. So my current sales at 450 a month, so 450 times the $17 minus break-even sales, that was 298, we calculated up here. So 298 times the $17, or 76.50 minus 5066, which we already had calculated here, 5066, equals 25.84. Margin of safety. All right, last one. The number of cakes they must sell to generate $2,000 in profit. Okay. Remember, target sales equals fixed plus target profit divided by the CM per unit, because we want to know how many cakes. It doesn't say the dollar amount of sales, it says the number of cakes. So our fixed cost, so target sales units, is equal to the fixed cost, which is $38.50, plus the target sales of $2,000, divided by the original $12.90. So that's equal to 453 units rounded. Cakes. Rounded, because we can't sell a partial cake. Well, we might be able to sell a partial cake. So 453 units. So you can see with just basic formulas, we can do a lot of prediction. Spend some time on this stuff. Have a good week.